We're now going to look at the last circle theorem, circle theorem 7. It's called the alternate segment theorem, AST for short. And this theorem states that you have a chord and a tangent that meet at a point. And what it says is the angle formed between a chord and a tangent is exactly the same as the angle formed at the circumference when you use the same chord. So just to repeat, the alternate segment theorem says that the angle between a tangent and a chord at a particular point is exactly the same as the angle formed at the circumference when you use the same chord. Note that the two angles are formed on different sides of the chord. So this angle is to the right of it, this angle is above or to the left of the chord. So it's the hardest circle theorem to remember. It's the hardest to visualize. So the key point is you need a chord and you need a tangent. And one angle is between the tangent and the chord. You then use the chord to draw a triangle such that it forms an angle at the circumference, and therefore the angle at the circumference will be exactly the same as the angle between the tangent and the chord. Okay, let's look at our last example in circle theorem. So again, we could be using any one of 7 circle theorems plus other little simple angle properties as well. So here's our diagram. It says find angles A and B below. So first up, it always makes sense to start close to the angle that you're given. So the only angle we know is 70. Now, first thing we can do is identify that the triangle here is isosceles because you're given 2 little ticks. So that means that the angle here at the top and the angle up here at the other top are both the same. So the angle here is going to be 70 as well. So because these 2 top angles are 70, if we add those together we get 140. If we take 140 away from 180, we'll be left with 40. So that means angle A is just 40 degrees. So our answer so far, A is equal to 40 degrees. And the reason we got 40 degrees was because, remember, we were working with an isosceles triangle. So IT for isosceles triangle. And then we used angles in a triangle to work out A. So, we know all the angles inside this triangle. We've now got to get outside this triangle and start to travel towards B. Now, B lies inside this triangle. If we could somehow work out this angle up here and this angle down here, then getting B would be really, really straightforward. Well, what we could do is actually use the alternate segment theorem to work out this angle down here, because we have a tangent, we have a chord, and they meet at a point. So the angle between a tangent and a chord is there. So there's an angle between a tangent and a chord. So I'm going to draw the tangent in. There's the tangent. There's the chord that meets the tangent to form this angle. If I then draw a triangle from the same chord, such that it forms an angle at the circumference, then the angle formed at the circumference is going to be exactly the same. So this angle and this angle are the same. So that little angle in there is also going to be 70 degrees because of the alternate segment theorem. Now, we need to try and get this angle up here, because if we can get this angle up here, then we know 2 out of the 3 angles in a triangle. Well, what we can see at this stage is that if you go to D, the line from D to B is a tangent, the line from D to C is a tangent, so we've drawn 2 tangents from the same point outside of the circle. So the lengths of those 2 tangents from point D to each point of contact will be the same. So I'm going to put a couple of little ticks. I'm not going to put one little tick, I'm going to use 2 because there's ones used here already. So these 2 sides are the same, so that means this is an isosceles triangle. So if these 2 sides are the same, then this angle up here, and obviously this angle down here, are going to be exactly the same. We've already worked out this angle to be 70, so that means this blue angle up here is going to be 70 as well. So we know this angle is 70, we know that angle is 70, add those together and get 140, and then subtract 140 from 180, and that's going to leave you with 40 for B. So let's just hit the rewind button there. How did we get B? Well, first of all, B is 40 degrees. And the reason for that, if you cast your mind back, is we used the alternate segment theorem to get this angle. AST. We then used the fact that the 2 tangents here were the same, so TT, 2 tangents. We then used the fact that we had an isosceles triangle to work out this angle here at B, so that was IT for isosceles triangle, and then finally we used angles in a triangle to work out D. AIT. And that's our answer. So angle A is 40 and angle B is 40. So that's now the realm in which we're entering. We're entering questions now where you could be asked to use any one of 7 circle problems and also other little angle properties as well.